All right, today we're taking a trip, a big one, over 1 billion kilometers away, to a place that is just full of mystery but is also, weirdly, familiar. We're talking about Saturn's biggest moon, Titan. This is a world that completely flips the script on where we thought the ingredients for life could even exist. So let's dive in and see what makes this moon such a fascinating, and maybe even a little spooky, twin to our own Earth.
Just imagine for a second, you look out at our solar system, and what do you see? Hundreds of moons, right? And pretty much all of them are what you'd expect, just barren, frozen rocks. But what if one of them wasn't like that at all? What if one was hiding a whole other world, wrapped in a thick atmosphere, with clouds and rain, and actual liquid flowing on its surface? Well, that's not science fiction, that's Titan.
I mean, the contrast is just, wow. On one hand, you've got your standard issue moon. No air, totally frozen, geologically dead. And then you have Titan, a dynamic, living world with this incredibly thick atmosphere and an active weather cycle. This kind of planetary behavior makes it totally unique. There is no other moon like it in our entire solar system.
So, how is any of this even possible? Well, it all kicks off with one incredible feature, its atmosphere. And listen, we're not talking about some thin, wispy layer of gas here. This is a heavy-duty, complex atmospheric blanket that literally changes everything about this world.
You know, for the longest time, this is all we could see of Titan, just this blank orange orb. Astronomers knew something had to be down there, but the entire moon was just shrouded in this thick golden smog. But that haze, that impenetrable haze, was actually the very first clue that Titan was hiding something spectacular. So when we finally managed to peek under that veil, what we found was just astonishing. Titan's air is about 95% nitrogen, and if that number rings a bell, it should. It's remarkably similar to the main ingredient in the air you and I are breathing right now. Just like here on Earth, Titan's atmosphere is mostly nitrogen. That makes them the only two bodies in the whole solar system with this feature. But here's the crucial twist. For us, the rest is mostly oxygen. You know, the stuff that keeps us alive. On Titan, it's methane. And that one chemical difference, well, it changes the entire story.
And the sheer weight of this atmosphere is incredible. The air pressure on the surface of Titan is 1.5 times what it is at sea level here on Earth. That blanket of gas is so thick, so dense, that if you could somehow stand on Titan, you could actually strap on a pair of wings and fly just by flapping your arms. Yeah, you heard me right. Fly.
Okay, so you've got this thick nitrogen atmosphere, and it's mixed with methane. What does that actually get you? Well, it gets you weather. But not like any weather you've ever experienced. On Titan, this simple little organic molecule takes center stage and runs the whole show.
It all comes down to the temperature. We're talking a bone-chilling minus 179 degrees Celsius. At that temperature, any water is frozen harder than granite. But methane, at that same super cold temperature, methane is a liquid. This lets it do the exact same job that water does here on Earth, creating a complete weather system that is a perfect alien mirror of our own.
And this cycle is going to sound incredibly familiar. Just like water here, methane on Titan evaporates from huge lakes and seas. It forms clouds in the sky, and then it rains back down, carving river channels into the surface. And this isn't just a computer model, you know. The Cassini spacecraft and the Huygens probe saw this with their own instruments, the rivers, the shorelines, the seas. It's a truly active, flowing world. I mean, the stuff Cassini found was just breathtaking. It spotted these vast seas of liquid methane and ethane. One of them, called Kraken Mar, is bigger than all of North America's Great Lakes combined. The mission mapped out river deltas, saw giant fields of dunes made of organic sand, and even found hints of cryovolcanoes. That's volcanoes that erupt icy slush instead of molten rock, which might be what's pumping all that methane into the atmosphere in the first place.
But okay, the surface is incredible, right? But the real magic, the stuff that gets scientists really excited, might be happening way up high in that golden haze. It's like a giant natural factory that's cranking out the exact kinds of molecules we think kick-started life on the early Earth.
This whole process creates something called tholins. Basically, high up in the atmosphere, sunlight and radiation from Saturn are zapping the methane and nitrogen molecules, breaking them apart. The little fragments then stick back together in new ways, forming these complex, sticky, reddish organic gunk. And these tholins are what give Titan its signature orange color. They're considered the precursors to life's chemistry. So just picture this, a slow, steady drizzle of these complex, prebiotic building blocks,
raining down from the sky 24/7, coating the entire surface of the moon. This constant supply of raw materials makes Titan one of the most compelling natural laboratories in the entire solar system. It's like we're getting a snapshot of the very conditions that might have led to life right here on our own planet, billions of years ago.
So we've seen this incredible world through the eyes of Voyager and Cassini, and it's been amazing. But what's next? Well, our exploration of this alien Earth is really, truly just getting started.
It's been this amazing journey of discovery, right? Back in 1980, Voyager 1 was the first to confirm that thick atmosphere. Then in 2005, the Huygens probe actually touched down on the surface, the first landing ever in the outer solar system. Cassini spent over a decade mapping the whole place, and now the next giant leap is already on its way.
Meet Dragonfly. This thing is a nuclear-powered car-sized drone, and it's set to arrive at Titan in the 2030s. It's designed to use that super-dense atmosphere to its advantage. It's literally going to fly around from place to place, land, drill into the surface, and analyze all of that rich organic chemistry up close, searching for those precious building blocks of life.
So, in the end, what does Titan really show us? It's like this cold, alien mirror of a young Earth. It proves that the complex chemistry needed for life isn't just for warm, watery worlds like ours. It can happen out there in the coldest, darkest corners of the solar system. And that leaves us with this huge, tantalizing question. If the ingredients for life are all over this strange, frozen world, where else out there might they be hiding?